Before the pandemic started, the management team of Addinsoft, which remember is the company that develops XLSTAT, was very excited by 2020. We had planned to celebrate the 20th anniversary of Addinsoft. The year had started wonderfully with record sales, and it seemed there were no worries ahead. When the pandemic started, I was pretty anxious about how much the world would be impacted, how many people would be affected, either in their health or their economic situation, and how that would influence Addinsoft's business and strategy. Everyone at Addinsoft reacted with a lot of courage and engagement, and we all understood that the pandemic was a challenge that would test us as a team and as a company committed to delivering excellent software and service to its customers. First, as many of our customers work in research labs, we made sure that anyone working on COVID-19 could get access to XLSTAT. We released a free COVID data analysis tool so that journalists and researchers from all around the world could monitor the impact. We talked to our users more than ever last year. We helped many of you get access to XLSTAT from home. We helped thousands of students learn and do their assignments while sheltering in place. We also made your life easier with reports that are more complete, better designed, and easier to export. Those who have been using XLSTAT for over 20 years know how much we are committed to always making the software more complete, reliable, and better in terms of usability. Let me go back to the subject of reliability. Statistical software is extremely difficult to stress test. The variability of what you can input is infinite. No matter how experienced a developer is, covering 100% of the situations that the software will encounter is very hard, though it remains an objective. It is a mixture of mathematical, numerical, computational, and memory space conditions. But when bugs happen, we are committed to solving them as fast and well as possible. And in 99% of cases, we have so far provided you with a solution within 24 hours. Because we want quality to improve even more, we have hired additional resources dedicated to quality management and added new machines to run more tests faster and more often. Our commitment to users is unique. Those who have struggled with open source platforms or with software makers that do not have this level of response know how bad it can feel when you face a problem and there is no one there to help. In the end, and to my surprise, we were rewarded with record sales in 2020, and December was our best month ever. Our users have been incredibly loyal, and we are so grateful to you. I would like to very sincerely thank you, our users and customers, for your exceptional and heartwarming loyalty during 2020. Thanking you is the least we can do. It is now time to reward you. What I'm going to announce would not have been possible without the Addinsoft team. Though we all lived challenging moments in 2020, either personally or professionally, I can proudly say the Addinsoft team has been fantastic. We are starting 2021 with the best team we've ever had. I'm so proud to be leading such an amazing group. Thanks to the abundance of caution and perhaps a pinch of luck, no one was sick a single day in 2020. As we added new features to our flagship product XLSTAT, we also initiated several major projects. The time has now come to share this news with you. First, we are very happy to announce 2 strategic partnerships. If you look at Google Trends, you can see how much the words uncertain and risk have been growing over the past decades, with a peak in 2020. On the Google Books Ngram Viewer, you can see risk is a concept that has been growing fast since the 70s. If your organization is not yet using risk analysis and management software, whether in the financial, production, or research departments, now is the time to make the move. Vose software has been delivering cutting-edge risk analysis software to all types of organizations for 15 years. XLSTAT already includes a robust but basic feature for Monte Carlo simulations. But now, with XLRISK, developed with Vose software and available at XLSTAT.com, you can explore much more complex problems while obtaining results much faster.
What is the probability that we are below budget? What is the investment that gives me the best return for a given level of risk? How much capital do we need to be 95% sure that we have enough for our project? So many questions that require clear and comprehensive software to help you answer them. XLRISK, developed by Vose Software and distributed by Addinsoft, is a powerful and simple tool that allows you to build, audit, and precisely test your risk models to enable you to make better decisions. XLRISK takes the form of drop-down menus built into Microsoft Excel. Automatically generate thousands of possible scenarios. They'll be displayed in a report including statistics and graphs that will help you answer all your questions. XLRISK relies on Monte Carlo simulation to offer you many features such as sharing hypotheses, extreme value tools, Markov chains, financials, and even insurance. Whatever your field, you'll find all the keys to carry out your projects. XLRISK, the software that makes quantitative risk analysis intuitive.
I'm very pleased to introduce David Vose, founder of Vose Software. He's one of the most renowned experts in risk analysis, who will tell you more.
Hi, my name is David Vose. I am the founder of Vose Software, a Belgium-based company specializing in the development of quantitative risk modeling and risk management tools. Our software products are the most advanced in each of their domains. We have Pelican, a fully quantitative corporate risk management system; Tamara, a cost and schedule risk analysis tool for projects; and Model Risk, which is a risk analysis modeling add-in for Excel that we will come back to in a minute. Risk analysis is about making forecasts of the future under different decision options, recognizing the uncertainty surrounding the outcomes of those different options, and choosing the option that best matches one's risk appetite. By applying quantitative risk modeling tools, we can progress from making statements like, "There is a small chance this investment will lose money," to more informed statements like, "There is about a 20% chance of losing money, which is driven mostly by uncertainty in the cost of steel. But if we lock in a steel price now at the market rate, we can cut down that probability to around 5%. I've been a risk analyst for nearly 30 years. In that time, I've had the privilege of working on wildly different risk-based decision problems across a great many industries. From how to stop the spread of antimicrobial resistance in foodborne pathogens like Campylobacter, to how much capital a bank should set aside to cover operational risks, or how a company should spend its money most effectively to manage cybersecurity risk. A common weakness, whether the problem is in science, policy, engineering, or business, is that one rarely makes the best use of available data to estimate as precisely as possible the true values of the parameters that go into our risk analysis models. Obviously, the better the quality of the inputs, the better the outputs. So this is a real opportunity that is being missed. The reason is that most risk analysts have very little, if any, statistical training, just as few statisticians have any training in risk analysis modeling. Statistics provides us with tools to express quantitatively how precisely we know the values of parameters we are interested in, or explore and quantitatively describe how variables influence each other. Risk analysis takes the best available information as its foundation and makes predictions of what the future might bring. Statistics and risk analysis are two sides of the same coin, and they share many of the same concepts. Using statistics, we can turn data into information. In the context of decision-making, having better information means simply that it becomes clearer which option is to be preferred. Now, how about bundling the capabilities of XLSTAT, the most advanced statistical add-in for Excel, with a version of Model Risk, the most advanced risk analysis add-in for Excel? Each is a natural complement to the other. Thierry and I found the idea very exciting and set about producing XLRISK, a software product based on the well-proven capabilities of Model Risk, but with the language support and flexible licensing options of XLSTAT. This is what I see as the first in a series of steps that will bring greater integration between the statistical and risk analysis worlds through the use of a shared modeling environment. I'm delighted to announce today that XLRISK has now been officially released. I encourage you to download a trial copy, which you can do for free from XLSTAT.com. If you find it useful for your work, you will also be pleasantly surprised at the price. Addinsoft sales automation, its efficient support team, and very well-controlled overheads means that XLRISK can be offered at a price that compares very favorably with other risk analysis add-ins that you can find in the market, despite it also being the most advanced and easy-to-use product. Thank you very much for your time. I hope you enjoy the rest of the conference, and with a little luck, for the next one, we will get to meet in person.
Thank you very much, David. In an increasingly challenging and globalized world, making a good decision is not enough anymore. When possible, you should make the best decision. Local Solver was created in 2007. This makes it a new player in the optimization software ecosystem. At Addinsoft, we know that getting visibility in a mature market is tough. You need to bring something new and valuable to users, or you will never take off. Local Solver has revolutionized operations research by adding a lot of intelligence into their software, enabling outstanding performances and breaking records one after the other. They make their competitors look old-fashioned. So we are delighted to announce we have been integrating their technology into our brand new XLOPTIM, which is, as of today, the best optimization software for Microsoft Excel. During testing, we were surprised to find out that not only is XLOPTIM a lot faster than the Excel Solver, which we expected, but XLOPTIM was also able, in some cases, to find the optimal solution, while the Excel Solver could only find a suboptimal solution. XLOPTIM is opening new horizons for those of you who want to make the best decision. Nicolas and Louise have prepared a video so that you can find out more about it before you download and play with it.
There's a solution to each problem. You just need to have the best tools to solve it. Whatever your area of expertise, you need a powerful, easy-to-use, and comprehensive decision support tool to help you make relevant decisions quickly. With the XLOPTIM Solver and its powerful computing core, you can quickly solve your optimization problems with quality solutions without having to write a line of code. XLOPTIM takes the form of drop-down menus built into Microsoft Excel. Get your results easily and instantly in an Excel spreadsheet, which you can edit at your convenience and share. XLOPTIM stands out for its computing power by integrating Local Solver, the world's leading optimization solver, combining exact such as branch and bound, and heuristic such as local and global search techniques. As a result, all the most in-depth optimization techniques are implemented so that you can make better decisions. The software compiles linear and non-linear optimization methods and meets the needs of many areas: supply chain, production, transport, logistics, e-commerce, energy, telecommunications, advertising, or again, finance. XLOPTIM, the solver for Microsoft Excel that combines power and simplicity.
You may feel it is already a lot, but there is more. We have also developed new data visualization software. We had noticed that some of you wanted to produce better-looking graphics and that the Microsoft Excel capabilities were not giving you the flexibility you needed. We have developed brand new software to publish striking data visualizations that will allow you to better communicate your results. ZENPLOT was born at the end of 2020, and after a period of beta testing, we are pleased to make it available to you starting today.
Creating striking visualizations is a primary issue for many companies. Whether you're addressing a team, an internal supervisor, or clients, you have to be clear, precise, and catch the attention of your audience. Data visualization is a formidable tool, which makes it possible to break this barrier between expert statisticians and their audience. Each visualization is unique, and it's difficult to be satisfied with pre-established lists of graphics, which only partially meet the needs on a case-by-case basis. By navigating through a clean, simple, and intuitive interface, ZENPLOT helps you to create your own visualization. ZENPLOT is an application in which you can create your projects by importing different data sets. By overlaying different layers such as point clouds, line, bar charts, etc., and linking the data to any of their characteristics such as color, size, thickness, shape, etc., the number of creative possibilities increases greatly. Export your visualizations in different formats such as PNG or SVG and easily integrate them on your presentation supports. Exchange your projects and save templates to reuse on new data. Get out of the pre-established graph lists. Create your own visualization. ZENPLOT, the data visualization software dedicated to advanced graphics.
For the past year, we have been working on the development of new data visualization software. We started from a fairly simple observation. There are different visualization software solutions on the market. Some facilitate the creation of dashboards and meet a need to visually monitor data that evolves in real time. Turnover, the number of visitors to a website, etc. These dashboards are made up of different, simple graphics from a pre-established list, with designs that are not very customizable. Other software includes the ability to manipulate the data through the creation of filters, pivot tables, selection of variables, etc. These programs let you explore the data through visualizations. This subject is not new. There are more and more tools that allow you to collect data, and databases need to be explored to extract the most useful information. Even if these software programs meet real needs, one aspect of data visualization is left out. Once your data is analyzed using various statistical methods, visualizations, and exploration, you have to move on to the next stage. How do you summarize the data? How do you communicate the results? And sometimes make them understandable to the average person? How do you catch the audience's attention by gathering as much information as possible in a single, effective visualization? These are the questions that many data visualization users face every day. Okay, now imagine that you have finally managed to condense all the information in a single image. Obviously, you want this visualization to be better than the simple graphics the usual software programs offer. How do you create this visualization? Many graphics libraries are available and allow an infinite number of possibilities. However, using them is complex. and learning them takes a lot of time. Some users go so far as to copy their initial idea point by point onto graphics processing software. What could be more frustrating than having the perfect visualization in mind and not being able to create it? Based on this observation, Addinsoft has developed ZENPLOT, the data visualization software for advanced graphics. With ZENPLOT, you can create 8 different layers. Each layer corresponds to a type of graphic. These layers can be superimposed and linked to different data. By superimposing these different layers, the number of possible visualizations increases considerably. ZENPLOT is available on PC and Mac, and its simple and intuitive interface requires very little learning. A project can be made up of 1 or more visualizations, which in turn can be made up of 1 or more layers linked to 1 or more datasets. Each feature of each element of the visualization can be customized. For example, size, color, shape of a point. There are 2 ways to do this: uniformly for the layer or by linking it to a variable. ZENPLOT integrates different themes that allow you to style visualizations in the blink of an eye. In ZENPLOT, you can annotate your visualizations with shapes, texts, or images for a maximum of creative freedom. You can also customize to a high degree the reading axes and the legend of the visualization. Your visualizations can be exported in different formats: .png, .svg, etc., so that you can include them in your presentations. You can also share your projects and your visualization templates simply by saving them in the .zen format. Now, it's up to you to think outside the box and create your own visualizations.
Thank you very much, William. Of course, our core product, XLSTAT, has not been left behind. It is such a pleasure to make it better year after year.
Data is an invaluable source of information in both academic and private research. Whatever your area of expertise, you need powerful, simple, and comprehensive data analysis software in order to get precise conclusions and make relevant decisions. With a multitude of features, XLSTAT helps you produce excellent analyses from your data according to your needs. XLSTAT takes the form of drop-down menus integrated into Microsoft Excel. Get your results easily and instantly in an Excel spreadsheet, which you can edit at your convenience and share. Export your results to Word or PowerPoint with just 1 click and prepare your reports in the blink of an eye. XLSTAT compiles all general statistical methods, including multivariate techniques, statistical tests, modeling, and machine learning. The software also offers specialized methods sorted according to different areas of expertise, such as finance, sensometrics, or marketing. XLSTAT is as flexible as it is powerful. Get the most out of your data now.
Some of you already know my colleague, Thalia, because you met her at conferences or exchanged with her by email. I'm pleased to let Thalia tell you more about what's new in XLSTAT.
As statisticians, we love forecasting, and we also love the uncertainties that come with it. Nevertheless, the year 2020 has surely put this love to the test. Who would have imagined that so many analyses, studies, and articles, including some using XLSTAT, will be dedicated to such an ordinary-looking virus? One thing is certain. This year has seen the generation of more data than ever before, in huge proportions. To analyze this data, increasingly powerful software is needed. And this year, XLSTAT has gone through, sometimes discreetly, some major advances. Despite working remotely, our team's creativity and mutual aid have been constant. And you, our customers, have pitched in as well. First, I would like to take you through our achievements of the last 12 months. 11 new features. have been integrated into XLSTAT. These features cover a wide range of applications to satisfy customers and users across different fields, from sensory data analysis methods to experiment designs and reporting tools. 20 new options have also been added to existing features. These options range from extra graphs and tables as part of the output to new parameters to tune up the dialog box and customize your model. Our R&D team published 2 papers in scientific journals. Every year we hire a PhD student to work on new development for XLSTAT. One of our goals is to reinforce collaboration between the private sector and academic institutions. Our teams gave 6 presentations at virtual conferences. And last but not least, our customer support staff helped 5,000 customers and users. This is not just about a number. I'm talking about 5,000 customers who got replies to their question in less than 3 hours on average by friendly and skillful agents. When bugs were detected, solutions were provided in less than 24 hours. So a big thanks to all of you who reported those issues and contributed to the improvement of our software. I would also like to mention another great achievement. XLSTAT remained for another year the most complete statistical add-on for Microsoft Excel. Today, it offers more than 240 features. For those who haven't yet had a chance yet to experience its capabilities, I encourage you to try our free trial version and let us know what you think, because your opinion and feedback count for us. Actually, some of our latest features have come as a result of customer requests, including dense front graphs, support vector regression models, or connecting XLSTAT to R. A new year had just kicked off. We are all motivated and confident that we will offer you an even more powerful tool with higher performance and a better user experience. We also want to give you expanded possibilities, such as access from everywhere at any time through our growing cloud application. Next, you will hear from Thierry. Stay tuned.
As you can see, 2020 has been amazingly busy at Addinsoft. We are so excited to see 2021 starting. We are so eager to serve you more and better than ever. And new products are on the way. Thank you again for making all this possible. Please continue to expect the best from us. Please make suggestions, requests, comments. It is so useful. Let me now invite you to 4 workshops where you can discover more about the new products and features while asking your questions in the chat box. You will, of course, be able to replay the workshops you missed. Thank you for your time. Thumbs up and special thanks to the team who prepared this event, especially Louise and Nicholas. I wish you a very happy and safe 2021.
Hi! This session is about XLSTAT's latest improvements and getting an idea of what it offers today. For this, I chose to show you a selection of new features and options that I believe will improve your user experience. First of all, let's talk about reporting enhancement. These up and down arrow buttons allow you to quickly move up and down any XLSTAT report sheet. Quite handy, isn't it? Let's go to the XLSTAT options dialog box now.
Here you can activate a couple of options to customize your reports. For example, display the description of your results directly in the spreadsheet, or automatically merge cells next to the results tables to easily add your notes. Finally, display an outline of the results report for a quick overview of the entire report. Let's see all this in practice. I'm going to run an ANOVA. By clicking here, we can quickly see the entire list of tables and graphs. Or click here to see the entire output at once. In this cell, we can add any note related to the table on the right. And finally, if we drag the mouse cursor to the left of the titles, a comment will pop up explaining the results. We've also been working lately on data preparation improvements. For example, the missing data feature. You can now deal with quantitative and qualitative missing data at the same time. The expectation maximization algorithm has been implemented for quantitative variables. For the qualitative ones, the NIPALS algorithm and replacement by a given textual value are now available. For example, you can replace an empty answer of a survey. New options are also available in the contingency table feature. You can now use a group layer to create a contingency table for 3 qualitative variables, also known as a 3-way crosstab. At the end of this report, we will find a crosstab table per gender, which is our layer variable, followed by bar charts with the frequencies of each category. Let's move on to the multivariate analysis tools, and in particular clustering after dimensionality reduction. A new button has been added to the XLSTAT output sheet, which allows you to quickly run an agglomerative hierarchical clustering after conducting a PCA or other dimension reduction methods. This allows you to gain time as you don't have to set up the clustering dialog box from scratch. Nonlinear regression models. New output has been added to evaluate uncertainty. Check the lower and upper bounds added to the model parameters table, but also the confidence and prediction interval curves displayed in the regression chart. Let's move on to another modeling tool, regression and classification trees. It's now possible to set up the tree parameters in different ways. Let XLSTAT detect the optimal tree settings using k-fold cross-validation, or manually enter the values of each parameter, or even set up a range of values and let XLSTAT choose the best combination of parameters. Apart from these essential statistical tools, we've been also working on more advanced field-oriented features. One of them is Bayesian networks. This popular decision-making tool is a probabilistic graphical model that allows you to reveal causal relationships between variables with an acyclic-oriented graph. For example, we can use this method to determine the factors such as the age and education level, explaining the use of certain transports by population. Bayesian networks offer a wide range of applications, including fraud analysis, medical diagnosis, and consumer behavior studies. Finally, several methods have been integrated in the sensory data analysis menu, including free sorting data analysis, class studies, and class data, commonly used in consumer studies. Now, I can see some questions in the chat box. For example, someone is asking, can we run an ANOVA for data with millions of rows? Well, the answer is yes, it is possible, but you need to use a special importation option in the XLSTAT dialog box. Let's open the ANOVA window and reset it. First of all, you need to go down there and click twice on this button so that the orange sheet appears. This means that you are ready to import a flat file like a CSV, TXT file containing millions of rows. We click here and we browse the file from our computer. Let's see, for example, this one. We can preview it if we wish. Okay, it seems fine. Set up, click OK. And now I should be able to select the imported variables from the list. Since we are doing an ANOVA, let's select quantitative variable and some qualitative ones here. Then click OK, and here we are. And second question, can I find Bayesian networks in all XLSTAT solutions? No. Well, this feature is only available in 3 packages: the XLSTAT Marketing, Life Sciences, and Premium. And another one is asking which are the next features you're going to add into XLSTAT. Yes, so actually we are going to announce by the end of January our first major release for 2021, which will include a couple of new features and improvements. For example, under machine learning, there will be a new method called support vector machine for one class, and it will be a non-supervised method. Then for design of experiments, you will see a new interface, newly designed interface for surface response designs, and also the possibility to add interactions in the model of surface response design. Thanks for your attention. Now let's talk about user experience, and in particular how XLSTAT is being used by 2 of our clients, Professor Raymond and Amy Blake, a senior research technician.
Hello, thanks for being with us today. You're a senior research technician at Vanland Research and Innovation Center and an XLSTAT sensory user.
Yes.
Can you tell us a little bit about the analytics part of your missions and how XLSTAT has been useful for your work?
Sure. So I use XLSTAT to analyze data from my trained sensory panel. So I manage a descriptive trained sensory panel. Most of the time we're performing descriptive analysis tasks, and I use XLSTAT to perform my ANOVA to determine whether or not I have product differences. I also use principal components analysis to create my sensory space and define my sensory space. And I use AHC, cluster analysis, quite often to determine what my overall product differences or similarities are, which I use actually very often. We use preference mapping when we also have larger projects where we are collecting consumer liking and consumer preference data. And I also use XLSTAT for our rapid techniques, like pre-sorting. I use XLSTAT for that analysis. And I really like using XLSTAT because I'm able to, this is not an eloquent answer, but it's not a one size. I'm able to go in and look at, I'm able to change so many of the parameters for my analysis depending on what I'm looking for. And I'm really happy with the outputs. So those are basically the techniques that I use most often. And we use exclusively in my department use XLSTAT for our data analysis.
Okay, thank you. So mainly exploratory data analysis techniques, some modelization with ANOVA, clustering, and sensory data analysis. Pref maps.
Yes.
All right. So what you like the most is the flexibility of the dialog box. It offers you quite a lot of options, so you can set it up as you like, and this way it fits the needs of your model. And as you said, it offers quite a large variety of outputs that you customize, personalize, I guess, within Excel.
Yes, I like the flexibility because our projects sometimes every project that we work on is a little bit different. And sometimes we're working with companies and they want to know very specific information. So an automatic analysis does not work for our group. So we're very happy to use XLSTAT so that we can get the output that we need. I like that it is easy to use within Excel. That's how we have all our files formatted. So
okay.
Yeah, all of our standard operating procedures for analysis use XLSTAT.
Thanks, Amy, for sharing this very useful experience. And I hope you will enjoy our workshops and case studies later on.
Thank you very much.
Thank you. Bye. Thanks a lot for joining us today. So you're Professor Raymond, specialized in environmental stress physiology and biochemistry in Canada.
Yes, I'm a full professor at Memorial University, and my area of specialization, as you have mentioned, include environmental stress physiology and biochemistry, as well as neurolipidomics.
That is right. So you have lots of students, I guess, and I know you're using XLSTAT Classroom. And actually, I remember back in 2017 when I presented to you for the first time XLSTAT, and you're using it and since then.
Yes.
So
yes, you're correct. So I have a large graduate program. Currently, we have 17 graduate students, a research manager, and 2 postdoctoral fellows. And we work across multiple disciplines. So even though I mentioned the 2 core area, the research program is a very multidisciplinary program, and we use a lot of metabolomics data and lipidomics data. And so we use XLSTATs to help us to analyze those data, particularly in a multivariate application. Okay. We also have a food lab where we also do sensory work, and so we also use XLSTATs to do some of the sensory evaluation in the food lab, and have also incorporated metabolomics in my lab biochemistry and physiology courses. And so XLSTATs is used in those courses for demonstration purposes of the statistical approach to analyze metabolomics data.
Okay, so you have been using it for quite a wide range of applications.
That's correct.
From omics data analysis, heat maps, sensory data analysis, etc.
That's correct.
Could you tell me how XLSTAT have been overly useful for your teaching, and what do your students appreciate the most about it?
Yeah. So like, a couple things in particular. So a lot of our data is collected in Excel or exportable to Excel. And so XLSTAT, as you know, is an add-on. So that gives us the ability to use the data in the format that we are being able to export it. A lot of students are very familiar with Excel. And so that familiarity environment really helps in terms of manipulating and working with the data. The other aspect is that we are getting into computational biology quite a bit with our metabolomics platform. And I have students come from a wide range of background. And some of these students, they're not familiar with, coding that you would actually need to do in like a higher environment or a SAS environment, which is what we originally was using. And with XLSTAT, I've done some of those in the background. It's easy to allow the students to, have an appreciation for the equations that are used to generate some of the output, but they don't have to learn all the minute details around coding to be able to make those work.
Certainly. Yeah. In particular, the solution you are using, the premium one, is really complete, because you can do from descriptive statistics, visualization, statistical testing, predictions, sensory data analysis, simulations, omics, etc. So
yes, and one of the things too is I encourage the students to look at different approach for different topics, and so almost all the PhD students they learn a new technique, and they have to bring that to their research program. In terms of, keep learning new things and applying new things, a new approach to their data. And this is a really great way. And then once they learn one, they teach the entire group, including myself, because sometimes my students teach me, some, features or approach that they've taken using XLSTAT. So it's been really, really, useful for us in terms of a number of things we can do. And it's a less cumbersome environment to learn compared to some of the other software that's out there that is also doing really good software, but it's just that, there's a lot of inputs that you have to put in there to get the output. And XLSTATs, allow you to get your output without that heavy investment in some of those background inputs that sometimes can be really, counterproductive.
Thanks a lot, Professor Raymond. That was really useful, and it's a precious feedback. I hope it will be helpful for people in academia like you. Yeah. And stay safe.
All right. Thank you. Thank you very much. And thank you for all your help with getting this platform set up in my research program. I appreciate it.
Thank you. Bye-bye.
Okay, bye.
Hello everyone, and welcome to this ZENPLOT demo. We're going to explore the interface using an example of a complex visualization with several different layers. For the demo, we've simulated a fictitious consumer study. Initially, several products were evaluated by several judges according to different sensory descriptors. There were 3 competitors already on the market, C1, C2, and C3, and 2 prototypes that we want to launch, P1 and P2. At the end of this study, statistical analyses were performed on the raw data in order to be able to create the data sets that will be explored in this demo. These analyses can be carried out using XLSTAT. A product that we will call the ideal product was simulated in order to better understand the consumer expectations. In this demo, we're going to walk through the ZENPLOT interface in order to create a preference map that can easily be integrated into a presentation later. A tutorial about preference mapping is available in the XLSTAT Help Center. When you launch ZENPLOT, you land on the home page, which displays the latest project that you've modified, some tutorials, and a few inspirations. Here, we want to create a new project in which we will realize a new visualization, the preference map or pref map. So to create a new project, click on the Add a Project button from the home page or the projects area. You must now import a first dataset. Each project can contain one or more. Here, we start by importing the prefmap background.csv dataset. To do so, you can either drag and drop it or select it from its folders. Once selected, hit the Continue button to go to the next step. Step 2 of the import is to choose the right setting to import your data. The Apply Settings button allows you to preview the data import with the current setting. We observe that in this data set, the separators are commas and the decimal separators are points. To make sure, we click on Apply the Settings. It seems okay. It is also possible to delete one or more variables from the import. Each variable is assigned a type: observations, qualitative, or quantitative. Here, the variables F1 and F2 are quantitative, as well as the variable score. Okay, this import seems to be set up correctly. Once the data has been imported successfully, you can click on Continue to enter the project. Once in the project, we start by renaming the top bar. Here we'll call it Sensory Study. By clicking on New Dataset, we can import the other dataset into the project. This is called prefmap products.csv. To perform the preference mapping, we start by drawing the background of the map using a heat map 2D surface layer. To do this, click on Add a Layer and select the heat map surface 2D layer. There are 8 layers available in ZENPLOT. We fill in the variables F1 and F2 in the X and Y coordinates, and we click on Confirm to create the layer. Okay, at the moment, all tiles have a uniform blue color. We're going to link the filling color of the tiles to the score variable. To do this, choose the Fill Color option, then click on the Link to a Variable button, and choose the score variable from the drop-down list. Since the score variable is quantitative, we must enter a color for the minimum, the median, and one for the maximum. A color gradient is therefore produced for each tile according to its value on the score variable. The background represents the consumer preferences. The products located toward the blue zone are the least preferred. The products located in the red zone are the most liked. Several themes are available, but each visualization can be personalized according to one's own tastes. We do not want to display the borders of the tiles. So, by clicking on the border options, we apply a line thickness of 0. Now that the background is ready, let's place the different products in the study. To do this, we create a new scatterplot layer, this time selecting the prefmap products dataset and filling in the X and Y variables as coordinates. The points are then drawn. Note that depending on the layer selected, the options bar on the right changes. Each layer has its own options bar. Okay, just so we don't get mixed up, let's rename the background and products layers. You can also move the layers to control the stacking order. Here, we want the products to be superimposed on the background of the map. The points are not all visible, so we will customize them. To modify the points, we select the products layer and we put their fill color to product type variable. To see more clearly, we select 3 new colors rather than those in the current theme. Red for competitors' products, white for prototypes, and green for the ideal product. To customize the borders of the points, you must click on the Border Options button. Now, we can thicken the outline of the points in a uniform manner without binding this characteristic to a variable, and we can change the color of the outlines to black. Now we want to identify the different products. There are 2 possibilities for this. 1, we can create a new label layer by clicking on the Add a Layer as seen previously. Or 2, you can click on the option Add Labels. This option also creates a new layer, pre-configured by default with the same coordinates as the scatter plot. All that remains is to choose the variable that corresponds to the labels. Here, it's product. We want the position of the labels to be adjusted relative to the coordinates of the points. There, the labels appeared. We immediately rename the layer in labels. Let's remove the outline of the labels. To do that, let's go to Border Options and apply a thickness of 0. We could also choose a background color, but here we want to leave the labels transparent. In order to customize the text, let's click on the Text Options button. Here we're going to increase the size of the font, and we bind the color of the text to the same variable as the color of the points, product type. Now we're re-entering the red, green, and white from earlier. Each time a characteristic is linked to a variable, it's automatically added to the legend. Here, the color of the text is the same as the color of the points. To remove it, go to the caption options and uncheck the text color. In order to be able to see the white color, we just edit the background color of the legend, choosing a light gray. Okay, the preference map is ready, but now we've got to annotate it. Indeed, although the background of the map represents consumer preferences using color coding, it also represents a sensory map. Each zone therefore corresponds to a sensory specificity of the products. The information is not present in this data set. It's an assessment that we have made on our data and that we want to add here to enrich our visualization. To do this, we just add an annotations layer by clicking on Add a Layer and select the annotations layer. The annotation layer does not need to be linked to a dataset. By selecting the text annotation, you choose its location using the mouse. We enter the sensory characteristics of the products located to the left of the map. Once the text is filled in, by clicking anywhere in the viewing area, you can access the advanced options of the annotation. Here, we're going to change the color of the text and the outline and modify the background color to make the annotation stand out more. Then just repeat the operation for the right side of the map. These over here are sweet and vanilla products. We can see that the prototype P1 and the competitor C3 are the least liked, and they're characterized by a rather sour taste and a liquid texture. Competitors C2, C1, and the P2 prototype are all very popular and are quite close to an ideal theoretical product. They are characterized by a sweet taste and a thicker nature. You can also annotate the visualization using shapes or images. Here, we just add a logo on the visualization by clicking on the Image Annotation button and selecting the desired location with the mouse cursor. You can then adjust the size of the image. This time, the visualization is really finished. Let's just save it by clicking on the Save button. When you return to the project's area, a preview is now available. In a project, you can create several visualizations, adding more as you go. To navigate through the different visualizations, just click on the Visualizations button. Each visualization can then also be deleted from the project. To export the visualizations in the project, click on the Export button, then select the desired format. Finally, if you want to share this project with somebody so that they can modify the design or add a new visualization, you can export it in the .zen format. So just go to File and Export. Likewise, to import a .zen file, just select Import File. It will then be available in the project's area. Thanks a lot for following this little demo. Now we'll answer some of the questions that I've seen come in on the chat. Okay, here's one. What are the 8 layers available? Okay, are you ready? Here are the 8 different layers. Annotation layer, scatter plot, line chart, bar chart, heat map or 2D surface, area chart, histogram, and labels. Okay, we got another question here. Are the axes customizable? Well, yes. We didn't actually look at this in this example, but check out in Axis Options, there are a lot of different possibilities. You can customize the axis range using a second axis, editing the grid, customizing the ticks, the axis line, and the tick markers. Editing the text, titles, or labels. You can also enter the title of the axes by clicking directly on them and typing it in. Okay, got another question here. Do the results necessarily have to come out of XLSTAT? Well, that's a good question. ZENPLOT can easily import any dataset with XL or .csv format. In this example, the datasets were built by XLSTAT, but that's not a prerequisite. Is that it? Okay, thanks everyone for attending this demonstration. Feel free to visit our site, zenplot.com, and download the 14-day trial version.
Welcome everybody to a demonstration of XLRISK. My name's David Vose, the director of Vose Software. I'm going to start with a very simple example, something that everybody can really understand. So here we have Excel, and you will see that there is another ribbon on top of the ribbon for XLSTAT. In XLOPTIM, you also have the ribbon XLRISK. And here we have a number of different icons, and over the course of this demonstration, I will go through most of these icons. Now, there is a great deal of capability within XLRISK, so I don't intend to try and explain everything to you, but I want to give you a flavor of some of the power of what you can achieve with XLRISK. So, in this example here, I'm deciding to build a house. And I'm trying to figure out how much it's going to cost to build that house. So I've got a number of different items. First of all, I would have to purchase the land, and inevitably I'm going to have to pay some tax on the price of the land. I'll have to pay some legal fees, and then I'm going to have to start with my basic building of the house. I'm going to lay the foundations, construct the walls, etc., etc. Now, what we will typically do is we will come up with our best guess estimate. So here is in the center column, in column D here, I've got my best guess estimate in thousands of dollars, euros, whatever. All right, so my best guess is that the cost of the land I'm going to purchase will be, say, $110,000. But I also recognize that it could be as low as $105,000 and maybe as high as $130,000. You'll notice that the distance between the minimum and best guess and between the best guess and the maximum is not equal. And that's normal. It's quite consistent in almost any field that your uncertainties will have some asymmetry to them. If it's to do with cost, it's a rule of the world that all sorts of things can go wrong, and so the cost can get larger and larger, but not many things can go very right to make the cost go smaller. So we tend to have that around our best guess, which is our most likely estimate, we'll have values that could be a bit smaller, but, inevitably they could be quite a lot bigger. Now, what one might do in a traditional cost analysis is to come up with your estimates of each of these individual items and then add them up at the bottom. And that's what we've done here. You can see it's a sum of this column. And then we might go for a minimum. So here is a second column of the minimum amount we think we might have to spend. And then we can see that it could be as low as $370,000. And we do the same thing for the maximum, and it could be as high as $460,000. In other words, we feel that this is our best guess, 404, but the range is 370 to 460. The question is, how likely really is it that it could be as low as 370? How likely is it could be as high as 460? And if we were trying to budget for the construction of this house, what is a reasonable maximum amount that we should budget for? This is a very simple, very powerful use of risk analysis. And we have all the data here that we need. So let's start off. And what we're going to do is we're going to add uncertainty into this column F. How do we do that? Well, we go into the XLRISK ribbon and we select a probability distribution. So I'm going to click on the cell, F4, which is going to be the uncertainty in the cost of purchasing land. I click on Select Distribution, click on Select Distribution here. I'll explain a little bit about some of these other items a bit later. And a window opens, and it gives me a list of all the different probability distributions that are available in XLRISK, and there are many. It's fair to say that almost everybody will use a tenth of the distributions available in XLRISK, but those distributions will vary very widely from one person to another. If you're in engineering, you'll be using lifetime distributions. If you're in finance, you'll be using other types of distributions of return. But here we're going to be using subjective distributions because these are our guesses. They're not based on any data. So we'll click on the selection subjective and we get a subset of all of the distributions available to us. Now, when you know your distributions, and for most of us, we probably just need 10 or so, you will know which ones to pick. For now, I'm just going to tell you that a good distribution to pick here would be something called PERT. PERT is an abbreviation for Project Evaluation and Review Technique. It's an old name because it comes from a very old technique, but it's a very powerful distribution to use, and it requires just these 3-point estimates: the minimum, the best guess, and the maximum. So let's click on that. All right, so we see a distribution on the top. We see how relatively likely each value is across this range here. And on the bottom, we see the probability of being less than that particular value. So what's the probability of being less than 4? We can slide this guy over here, and we can read off some numbers on the table on the right. All right, so I want to pick the values from my spreadsheet. I go into the little control at the top left-hand corner. I select icon here, and I select the minimum distribution. Okay. Then I go to the next one. And the final one. And now you'll see the distribution is showing a range that starts at 105, which was our minimum cost, goes up to 130, our maximum, and it peaks. It has a most likely value of 110. So you see that the curve is maximum here at 110. Let's just insert that into the worksheet with a click. And what you will see now is a very strange number, 120.09. Where did that come from? Okay, well, what is entered into the spreadsheet is a function equals Vose, which is from our company, Vose Software, and then PERT, because that's the distribution we selected, and the 3 parameters. If I hit the F9 key, which is the spreadsheet recalculate, you'll see that this number changes. What's it doing? It's generating a random possible scenario. So for this purchase land item, it could be that it's $113,000. But if I keep hitting the F9 key, it could be 111, 115, etc. This is on the spreadsheet performing what we call a Monte Carlo simulation. All right, why do we have these particular numbers? Well, if I just click on the view function, which you see here, because I'm in a cell that's got one of the XLRISK functions, by clicking view function, I can pull back up that view. And you can do this with almost any of the functions within XLRISK. If you're in that function, in a cell in that function, and you don't know what it means, all you have to do is click on the view function and some kind of visual interface will pop up, which will give you a good idea of what's going on. You can see that value 106. That's a value that's around here, somewhere around the most likely. You can see that the vertical axis is representing those values more likely to occur. We might occasionally get a value out here at 125, but it's relatively likely to occur, unlikely to occur. All right. Now, in a risk analysis model, what we typically do is we want to nominate variables in the model, uncertain variables, as inputs and others as outputs. I'll explain a little bit later how we come to use those. But this is clearly an input into our model. So we need to click on this output input icon and select mark output input. And here we have a little interface that allows us to say what we want to call it. Well, we're going to give it a name. Let's click on there and select purchase land. And then we can say what units we want to apply, and here the units are going to be thousands of dollars. So I'll just put K for thousands. Is it an output or an input? It's an input to our model. So I click on input, then click on OK. So we've put in a formula into this cell, and if I show you that formula on screen, you can see that it's using relative references. So B4, C, D, E4, they don't have any dollar signs on them, so they're not fixed. And that means that I can copy the formula down if I want to. So let's try and do that. I'll go copy, and then I'll go and paste the formula. And you'll see there's a problem down here, but let's come to that in a little minute. Now, you'll notice I haven't added copied the formula into the land purchase tax, because this is exactly 5% of whatever the price of the land was. Sample something between 5.3 and 6.5 when we're taking a different sample for purchased land. We need this to be exactly 5%. So let's write that this is 5% of whatever the actual outcome land purchase price would be. So we write equals 5% times that value. All right. So I've copied the formula all the way down, but I've deliberately made a mistake. You can see here that the decoration costs, I've got a minimum of 11, a best guess of 13, and a maximum of 12. Well, that's not possible. If I was to go into here and delete the Vose input part, you will see what happens is that the function, the Vose PERT function, actually returns an error, and that's a very, very useful tool. So instead of simply going hash value exclamation mark, your guess is as good as mine as why this isn't working, it doesn't do that. It tells you that the mode must be between the minimum and maximum, and it clearly is not. Now, if I was to change the number, then this will work. So if I made it 14, now everything's fine. All right, I'll just copy that formula down so we have it as an input as well. And we've almost finished completing the model. You'll see down here that we've summed the column of costs. And again, each one of these is a random scenario. So if I was to hit the F9 key, each time I do, we're generating a different scenario. Sometimes the land purchase might be a little less, sometimes the legal fees a little bit more, etc., etc. But in order to have a good idea of what the real total cost might be in the ranges, I don't want to just keep hitting this F9 key. That's not going to give me a good idea. What I want to do instead is see a distribution of what those total costs might look like. And to do that, I go into the XLRISK menu, I select outputs and inputs, and I'm now just going to mark an output. Right, so we give it a name, same idea. So total cost is the name. And we can use the units, and let's use K again. And it's an output, not an input, so I just click OK. And what you see now is that it's added not Vose input, but Vose output. And again, it has the reference to the label for what this thing is going to be called and the units. And I finished my model, so I can save this. And I can run the model. So what I need to do to run the model is decide how many different samples or different scenarios I want to generate. In general, you can just use about 3,000. So let's go in here in the settings. I'll change this to 3,000. That tends to be enough for most purposes. And then I'm going to run the model. You'll see on the bottom right-hand corner, it's showing the progress at 60, 70, 80, 90, 100%. And when it's finished, you'll see that there is a new window that opens, which is the results viewer. By the way, the XLRISK is one of the fastest simulators, if not the fastest simulator, of Monte Carlo simulations on the market. All right, so in this window here, where I've got the results, I can create any number of different graphs that I might find interesting. First of all, let's look at the left-hand side. We've got the list of all the different simulations. In this case, we only run one simulation, but we might have run several different options and repeated simulating the model to be able to compare which option is the best. We only have one output, which is the total cost, and we have a list of all these different inputs. So I'll just quickly kill all of these different graphs and start again. And I'll insert a histogram. And this is a histogram of the output, the total cost. And what do we see? We see that the total cost is realistically going to be around somewhere between $390,000, maybe up to $425,000. Most likely value of somewhere around 408 or so. Well, that's very interesting. Not only can we see the range and the most likely value, but we can also see the probability of being between or above or below different values. So for example, we can see here at a roughly $400,000, it's a 5% chance it's going to be less than that. So you wouldn't want to be budgeting for $400,000. Similarly, $419,000, you've got a 95% chance it's going to be below that, so a 5% chance it's going to be above. That's probably a realistic amount to budget for. It would be interesting to be able to compare that against our original values. So let's have a look. You can see here that our minimum, when you added them together, all our minimum costs, we arrived at $370,000. Where does that sit? $370,000, in fact, sits way over here to the left. It's an absolutely impossible scenario. The reason for that is that all of those costs at the same time would have had to arrive at that minimum value. So that's tossing a coin hundreds of times, if you like, and expecting to get heads every single time. It's just not feasible. Similarly, it's not feasible that 462, pardon me, is the maximum. 462 is way over here to the right again. So we know that if we follow that more traditional way of just putting in the minimum cost, putting in the maximum, add them up, we're not going to get a realistic bounds. But surely if we add up the most likely values, then we do get a realistic number. Well, that was 404,000 here, but where does it sit? In fact, that's pretty optimistic. $404,000, which is around there, we only have about 28–30% chance that it's going to fall under that cost. And you might ask yourself, why? The main reason why is because these distributions are skewed to the right. They have a longer tail to the right than they do to the left. Or in other words, if you take one, for example, plastering, very typically, 28,000 is your most likely, but it could be 3,000 less, but it could be 5,000 more. So there's more chance of it being a higher value than this most likely than it is being lower value. In this very simple example, we can see how helpful quantitative risk analysis is in getting some realistic idea of how much your budget should really be. Now, we have a lot of other different graphs that we could choose, so let's add a new one. We can, for example, add a cumulative distribution. Now, the cumulative distribution is exactly the same information that is presented in histogram, but in a different form. So, for example, you can see there's a 5% chance of lying below about 400,000. That was the same number we had before. A 95% chance of lying below 420,000. Again, same numbers we had before. The vertical axis here represents the chances of being below that horizontal axis value. So you can move these sliders around, you can hit a particular target and ask yourself what's the chances of being below some specific number. So for example, if you were saying, all right, I'm going to budget 420,000, what's my chances of being below that? 96%, give or take. Well, that's pretty confident. So that would be a good number to take to the bank. Now, we also might ask ourselves, well, why is this cost so uncertain? What's driving the uncertainty in the cost? And for that, we can use a number of different graphs. But the best one to use is the tornado. So we'll add a tornado chart. What the tornado chart is doing is it's showing you how much, on average, the total cost of the project would be if your land purchase was at a very low value versus if your land purchase was at a very high value. That means that the length of this bar reflects how much uncertainty is being added into the total cost. And you can see from this graph that the purchase of land is by far the greatest driver of uncertainty in your total project cost estimate. We can also insert some statistics. So for example, let's do that here. Here we can see all of the different items, whether outputs or inputs. So first of all, we've got the total cost, and that's an output, and you've got all these others here are the inputs. And you can read off a bunch of statistics. They're the same statistics that you can read in a tornado chart, or you can read in any of the cumulative or histogram curves. At the same time, what we can do is we can go into the Home tab, and we can then go and create a report. So if you want to have a particular report in a PDF, then you can select Report, you can pick some variables you want to include, and you can send it off to Microsoft Excel, PowerPoint, Word, or PDF. So you have a hard copy, if you like. But what's very interesting about this particular results viewer is that you can also simply save the results. So if you save the results, you can then send the file off to a colleague who can open it, and they don't need to have the model. They can already view all the graphs that you've created, just as you're seeing them here, and they can even create new graphs themselves without having any extra need for modeling or other information. Everything that is needed is in that XLRISK results viewer file. This concludes a very simple example of how you can use XLRISK to perform a cost analysis. Bear in mind that this is just a simple example we're trying to offer because it's something that everybody can understand. But there are many, many applications of risk analysis. So I thank you very much for enduring this presentation. You're very welcome to ask questions and submit them through the conference, and I'm sure that we'll be happy to answer them. Specifically, I will be happy to answer them if they're very technical. Thank you for your time, and enjoy the rest of the conference.
In this video, we're going to show you how to solve an optimization problem in different ways using our new XLOPTIM software. Before we start our demo, it's important to define a few basic concepts. The objective function of a problem will represent the expectation around the problem. For example, one may want to maximize a profit or conversely minimize a cost. The role of the solver will therefore be to vary the values of the problem in order to optimize the objective function. These actionable values, more often known as problem variables, can be interpreted in a variety of ways. They may represent a quantity to be produced, the choice to purchase or not, and so on. They can therefore be of different natures: continuous, discrete, Boolean, etc. It is often the case that the variables cannot encompass all possible values because of certain limitations. For example, a budget you cannot exceed, limits on the time you have, etc. All these restrictions in the problem will be modeled by mathematical constraints. XLOPTIM is a solver that allows you to solve linear, nonlinear, and mixed problems using the computational power of a local solver. Once you've installed the program, the menu XLOPTIM adds to the Microsoft Excel ribbon will allow you to choose the language, access help, tutorials, and various other options. To open the modeling interface and solve the problem, simply click on the Modeling button. After that, all you have to do is choose the cells containing the objective function, select the variable cells, and define the constraints. We have decided to illustrate our demonstration using a problem that is well known in computer science literature, the bin packing problem. Suppose we have a number of rectangular objects to store in bins. We know that these bins are limited in length, but that the width of the objects is equal to the width of the bins. This amounts to considering a one-dimensional problem where the objective will be to minimize the number of open bins while respecting the size of the bins. If we assign an object to a bin, then that bin will be considered open. The classical linear integer program comes down to considering the problem with two groups of variables: The first group, Xij, indicates the assignment of object j to bin I, and the second group, Yi, indicates the opening of bin I. The objective function is therefore the sum of all the y variables, which comes down to counting the number of open bins. We must also select the cells that we have previously filled with the left side or the right side of the constraints. For each line of our set of variables x, the sum must be equal to 1, which is equivalent to saying that an object will have to be assigned to a bin. To ensure that the total length of the objects added does not exceed the capacity of the bin to which they have been assigned, we can use the sum product function here. This function allows you to calculate the product of two or more vectors. All the functions that have been used so far are linear, but we will demonstrate how we can reduce the number of expressions used by slightly changing the model. In this model, we remove the yi variables, and to find out if a bin is open, we use the if function. So if the sum of a column is greater than or equal to 1, it means that we have assigned an object to this bin, and therefore that we have potentially opened this bin. Therefore, the objective function will be constructed so as to minimize the sum of the if functions. In this model, we are combining linear and nonlinear functions to make the model as simple as possible. But we can do even better than that. XLOPTIM also allows you to use the max function. We can consider that bin I is open if the maximum of column xi is equal to 1. The maximum of each column will necessarily be equal to 1 because the variables are Boolean. So, the objective function will be to sum up all of the maximums of each column. This allows you to avoid combining the if function with the sum function, simplifying the model. Finally, the last model we will look at allows you to save a lot of time when the problem is bigger. Indeed, for 60 objects, we go from a total of 3,660 variables right down to 60 variables. The number of expressions is therefore also reduced. In this model, we have removed the xij variables and the yi variables and replaced them with a set of zj variables, which represent the number of the bin to which we have assigned the object j. We will therefore try to minimize the maximum number of the zj's, which represents the last bin to which we have allocated an object. These variables should therefore be between 1 and the upper limit of the number of potentially usable bins. In our case, we consider that in the worst case scenario, each bin will contain a single object, which means that our upper limit is equal to the number of objects. In addition, we have a set of nonlinear constraints, since we're using the sum-if function. For each bin number, we check to see if it is used in the zj list. If it is used, then we add the length corresponding to the object j. Following the resolution, XLOPTIM automatically updates the spreadsheet if the solution is feasible. You can always check out the tutorials on the XLOPTIM website if you need help modeling your problems. Okay, so I'm checking out the questions you asked in the chat during the demonstration. Here's one. What kinds of algorithms do you use to solve the problems? Well, mainly we use local search algorithms combined with exact algorithms that are used to prove the optimality of the solution. Here's another question. What other functionalities does XLOPTIM have? Well, for the moment, only the solver, which should allow you to solve the majority of your problems. But we're working on new tools, and they're coming soon. And here's another one. Have you compared XLOPTIM results with those of other solvers on the market? Yes, we have. During our benchmarking of competitor software, we noticed some errors during the resolution, particularly in general parsing. We can say that when the resolution worked, XLOPTIM always proposed better solutions than the competitor software did, and they were reached very quickly. Do not hesitate to contact our team if you have any further questions. You can get in touch through our website, XLOPTIM.com. Thank you all for watching this demonstration, and we hope to see you soon.